On July 1st, 2025, an automated telescope in the mountains of Chile found something it was not looking for. Not a threat, not an asteroid on a collision course, not another ordinary comet wandering in from the cold outer edge of our own solar system. Something stranger. A small, faint object was moving across the sky at roughly 137,000 miles per hour. Fast enough that, when astronomers calculated its path, the answer immediately looked wrong for a normal solar system body. It was curving around the sun, yes. The sun's gravity was bending its trajectory, but the curve did not close. It was not in orbit. It had never belonged here. When astronomers traced the motion backward, the path did not lead to the asteroid belt. It did not lead to the Kuiper belt. It did not lead to the Oort cloud, that enormous distant reservoir of icy bodies that surrounds the sun like a frozen shell. It led outside, beyond the sun's family, beyond the gravitational territory where the solar system can claim ownership. The object was named 3I Atlas, the third confirmed interstellar object ever detected passing through our solar system, after 1I Oumuamua in 2017 and 2I Borisov in 2019. And unlike so many cosmic stories, this was not a story about danger. It was not coming for Earth. It was not an apocalypse with a calendar date. It was not a mysterious signal demanding an answer. It was a visitor, a piece of another star system crossing ours once, briefly, at high speed, carrying chemistry from a place we cannot identify and may never find. It came in from the dark between the stars. It moved through the planetary neighborhood. We turned almost everything we had toward it, and then it began to leave, permanently. To understand why 3I Atlas mattered, you have to understand what interstellar means in this case. Most comets look like travelers, but they are actually citizens. A comet can spend thousands or millions of years far from the sun, deep in darkness, moving so slowly that its orbit seems almost impossible to imagine. But if it belongs to the solar system, the sun still owns it. Gravity has it captured. It falls inward, swings around the sun, and eventually goes back out again along a closed path. 3I Atlas was different. Its orbit was hyperbolic. That means the sun bent its path, but not enough to keep it. It arrived with a speed so high that solar gravity could only redirect it. At closest approach, the sun accelerated it even more, to roughly 153,000 miles per hour. Then, as it moved away, it gave that borrowed speed back, slowing toward the same velocity with which it entered. That is what a true interstellar visitor does. It does not come home, because this is not home. The sun was never going to keep 3I Atlas. The solar system was never a destination. It was an encounter. And because encounters like this are rare to us, not necessarily rare in the galaxy, but rare to our telescopes, astronomers moved quickly. If stories like this are why you come here, stories where real objects from real space turn out to be stranger than fiction, subscribe to the channel. The next visitor from another star may already be on its way, and when it appears, we will not have much time to understand it. Because the first problem with studying an interstellar object is that it does not wait. A planet will be there next year. A moon will be there next decade. An interstellar comet is different. It crosses the solar system like a stone thrown through an open window. By the time you know what it is, the clock is already running. So NASA and other observatories turned what they could toward 3I Atlas. Hubble imaged it and helped narrow the size of the nucleus, the solid icy body hidden inside the coma. Webb examined its chemistry in infrared light. Ground-based observatories measured its spectrum. Spacecraft that had been built for entirely different missions suddenly became useful from unexpected angles. NASA later listed observations or attempts involving Hubble, Webb, TESS, SWIFT, Sphere-X, Perseverance, Mars Orbiters, Europa Clipper, Lucy, Psyche, Parker Solar Probe, Punch, and SOHO. No one designed that fleet for 3I Atlas. It was already out there. And for one brief season, the solar system had something worth turning toward. What the observations showed was, in the simplest terms, a comet. Not a smooth alien needle like people imagined when Oumuamua passed through. Not a silent artificial object. A comet. A small icy body warmed by the sun, releasing gas and dust into space, surrounded by a coma that glowed around a nucleus too small and too hidden to measure easily. But the moment you say comet, you risk making it sound ordinary. 3I Atlas was not ordinary. Its chemistry was strange. The first major surprise was carbon dioxide. Webb observations showed a coma unusually rich in carbon dioxide compared with water. Carbon dioxide is common in comets, but the ratio in 3I Atlas was high enough to stand out sharply from most comets native to our own solar system. That matters because comet chemistry is not random decoration. It is a record of temperature, radiation, formation distance, and storage history. A comet is frozen memory. Its ices were built in a particular environment, then preserved, sometimes for billions of years, until sunlight finally warms them enough to escape. If 3I Atlas was rich in carbon dioxide, one possibility is that it formed in a region of its original system where carbon dioxide ice was easy to trap. Another is that its surface had been altered by long exposure to interstellar space, forming a crust that suppressed some gases while allowing others to escape. Another is that we are only seeing one stage of a complicated object changing as solar heat reaches deeper layers. That is the frustrating and beautiful thing about a visitor like this. It gives us data, not a biography. The nucleus itself remained uncertain. Early brightness estimates allowed people to imagine a very large object, and headlines did what headlines always do. They made the largest possible number sound like the answer. Later Hubble observations narrowed the estimate dramatically. NASA's range placed the nucleus somewhere between about 440 meters and 5.6 kilometers across. That is still a wide range. But it is not Manhattan-sized certainty. It is not a clean photograph of a solid surface. It is a moving, active comet wrapped in dust and gas, seen at enormous distance, forcing astronomers to separate the light of the nucleus from the light of everything escaping it. With 3I Atlas, the honest answer is often not a single number. It is a boundary. This much is possible. That much is ruled out. The rest waits for better data or for the next visitor. Then Webb found methane. For the first time on an interstellar visitor, the James Webb Space Telescope directly detected methane gas. And the timing mattered. The methane appeared after the comet had already gone around the sun and was moving outward again, suggesting that it had been buried beneath the outer surface and released only after solar heat penetrated deeper into the icy body. That is an extraordinary clue. A comet is not just a snowball. It is a layered archive. The surface is processed by radiation, heating, cooling, impacts, and time. The deeper layers may preserve something closer to the original material from the system where the object formed. Methane emerging late means the outer skin and the inner reservoir may not tell the same story. The surface says one thing. The buried ice says another. And then came the water. In 2026, observations with the Atacama Large Millimeter-Submillimeter Array measured deuterated water in 3I Atlas, water in which one of the hydrogen atoms is replaced by deuterium, a heavier form of hydrogen. This is not just an exotic molecule. It is a chemical fingerprint. In cold environments, heavy water forms more readily. The ratio between ordinary water and deuterated water can tell scientists something about the temperature and conditions under which the ice formed. In 3I Atlas, the measured proportion of deuterated water was at least 30 times higher than in comets from our own solar system, and far higher than the ratio in Earth's oceans. That one measurement changed the emotional weight of the object, because now 3I Atlas was not merely from somewhere else. It may have been from somewhere colder. Older. Some estimates suggest it could be around 10 to 12 billion years old. That number is still an inference, not a label printed on the object. But if it is even close, then the ice leaving 3I Atlas began forming long before the Sun existed, before Earth existed, before the solar system had planets, moons, oceans, or life. We were not looking at a rock that happened to be passing by. We were looking at preserved chemistry from another chapter of the galaxy. Naturally, because the object came from another star system, moved fast, had unusual chemistry, and arrived after Oumuamua had already trained the public imagination in a certain direction, the alien probe question appeared almost immediately. Harvard astrophysicist Avi Loeb argued that some aspects of 3I Atlas were worth examining under the possibility of an artificial origin. He had made similar arguments about Oumuamua, and as before, the suggestion attracted attention far beyond the evidence. This is where the story needs discipline. There is nothing wrong with asking unusual questions. Science survives by not refusing questions merely because they sound strange. But a question is not evidence. A possibility is not a detection. And the fact that an object is interstellar does not make it engineered. Most astronomers pushed back strongly, not because they were afraid of the idea, and not because they were protecting some official story, but because the data looked like a comet. An unusual comet. A scientifically valuable comet. But a comet. So researchers checked the obvious thing. The SETI Institute used the Allen Telescope Array to search 3I Atlas for radio technosignatures across a wide range of frequencies. They collected more than 7 hours of data. They detected tens of millions of narrowband hits, as modern radio searches always do, because Earth is loud. After filtering, the remaining candidates were consistent with human-made interference, not with a transmitter on the comet. No signal, no technology, no artificial transmitter. As far as the evidence shows, 3I Atlas was not a probe, not a craft, not a message aimed at us. And that does not make it less interesting. It may make it more interesting, because an alien probe would be one kind of miracle, but a natural comet from another star system is a different kind. It tells us that planet building is not local. Icy bodies form elsewhere. They are thrown out. They survive interstellar space. They cross other systems. And when we are lucky, they pass close enough for our instruments to read the chemistry written into them. That is not a message with words, but it is still a message. It says the same physics that built our comets also built comets around other stars. Not identically, not with the same ratios, not the same ices, not the same history. But the process is recognizable. Disks form around young stars. Dust sticks. Ice accumulates. Small bodies grow. Planets scatter them. Some are ejected into interstellar darkness. Then, after millions or billions of years, one of them crosses another solar system and briefly becomes visible. This is what 3I Atlas was. A sample without a sample return mission. A cometary core we could not touch, but could read from a distance. A body whose orbit said outside, whose gases said cold, whose water said ancient, and whose radio silence said natural. By August 2026, the encounter was already ending. 3I Atlas had passed the inner solar system and moved back outward. It had passed Jupiter's distance and was heading away from the Sun, back toward interstellar space. We will almost certainly never see it again. Not because we will lose interest, not because it will be destroyed, because its path makes return impossible. A bound comet can disappear for centuries and come back. 3I Atlas cannot. It borrowed the Sun's gravity for a turn and then left with its freedom intact. That is the part of this story that feels almost personal, even though nothing about the object is personal. It came through once. We noticed it. We measured what we could. And then it went on. If you were in charge when the next interstellar object is discovered, would you spend billions to launch a fast intercept mission, even if the object might turn out to be only ice, dust, and silence? Or would you save those resources for worlds closer to home, where the science is easier and the return is more certain? Leave your answer below, because this is one of those questions where the value of knowledge is the entire argument. As far as the evidence shows, 3I Atlas was not an alien probe. That is the point the data actually supports. It was something quieter, colder, and maybe more valuable. A genuine fragment of another star system, passing through hours after a journey we cannot reconstruct, carrying ice that may have formed before our sun was born. It asked nothing of us. It left nothing behind except data. No warning, no message, no return. Just a moving point of light, briefly caught by human instruments, briefly understood, and then released back into the dark between the stars. And somewhere out there now, beyond the planets, beyond the reach of any spacecraft we currently have, 3I Atlas is moving on, still carrying its old ice, still carrying the chemistry of another home, still heading toward whatever waits next. Not orbiting, not returning, just passing through the galaxy, the way it passed through us.